The strategy pattern. The strategy design pattern is once more amongst those design patterns which are so widely used that we don't think of it as a pattern at all. You'll probably claim, oh, that I always write code this way in Java. However, it's the Java framework which forces you to write code that way. And when you write code in that particular style, we'll talk about what that style is, you're using the strategy design pattern. What does the strategy pattern give us? Now, in code, there is often an objective that we want to achieve. We write code for a reason. The strategy pattern basically says the objective that you want to achieve can be decoupled or separated from how you achieve it. So the algorithm that you use for achieving that objective can be determined at runtime on the fly. And there can be several different ways by which you can achieve that objective, and you simply plug in the way that you're interested in at that point in time in code. So at runtime, you figure out the strategy or the algorithm which you'll use to achieve your objective. That, in a nutshell, is the strategy pattern. Now, everything is best understood using examples. So we'll be looking at a whole bunch of examples which use the strategy pattern. Let's now look at a very simple example which uses strings. So we have a whole list of strings, and let's just assume for now that they are names of people and we would like to sort them. It so happens that the program that we are trying to write will have this list appear in a user interface in the form of a table. And we want to allow the functionality where a user can right-click on this table and pick different ways to sort. It's very easy to imagine here that there are a whole host of algorithms you could use for sorting these strings. Let's just say that we want to sort it in lexicographical order. You'd sort it in a certain type of way. If you want to do it in reverse lexicographical order, your algorithm would be a little different. If you ignore case or if you don't ignore case. In each of these cases, you'd have a different sorting algorithm. You could even have a custom order where the name Donald Trump always appears first in the list. So all of these are different ways of achieving the same objective, which is to sort this list of strings. Now, if any of you are familiar with Java programming, and I assume most of you are, there is a pretty standard way of handling this. What will you do? You'll create a whole bunch of algorithm objects. These algorithm objects specify how to sort that list. And in Java's case, each of these algorithm objects implement the interface called comparator. A comparator is a generic interface, and in this case, because we are comparing strings, we pass in string as a template parameter. This will be used to compare two strings. A comparator is a single method interface which implements the compare method. This compare method takes in two strings and specifies which of those two strings come first. That's the single purpose of the compare method, specifying which of the two input strings come first. Int is the return value of the compare method, and it takes in a string s1, s2. It takes in any object, but in our case, it will be a string. Now, how will this comparator determine which one comes first, and how will it convey this information? It's done by the return value, the integer. It returns -1 if the first string is less than the second one, 0 if the strings are exactly equal, or +1 if the first string is greater than the second string. This is the language that the comparator speaks, and this is the contract the comparator has in terms of its return value. This is how the comparator tells us which of those strings is greater. Now let's go back to the algorithm objects. What logic does it use to specify which string is greater? Now, each algorithm object can use its own logic for determining this order. That is what the algorithm is. The core of the algorithm is to determine which string is greater. And depending on what it's trying to do, whether it's lexicographical, ignoring case or not, the algorithm changes. So each algorithm or object specifies its own logic. Now, once you have all these algorithm objects ready, we can simply use a standard function which Java as a library provides us. Java has this very useful collections class which has a whole host of static methods which provide very useful functionality. And the one we'll use here is collections.sort. This can take in any list. In our case, it's a list of strings, and then it takes in a comparator. So we have all these different algorithm objects which can sort these strings using different algorithms. We can simply pass these in to this collections.sort method. So we have the list which has to be sorted, and we have the comparator which determines the logic of sorting. This is the strategy pattern at work. The strategy pattern is used to specify a behavior. And in the example that we've just seen, the behavior is how to sort. The objective is to get a sorted list. But how we want to sort that list is specified by the strategy. Now this strategy is specified on the fly when the user selects a sort method from a user interface. So though we have all these algorithm objects ready, we don't know which one is going to be used unless the user specifies some input. So we sort it by passing these algorithm objects as member variables. This is important to understand and internalize. The algorithm objects are passed as member variables into a function which allows us to sort. It's a defining characteristic of the strategy pattern that it uses composition, the use of member variables, to specify the strategy rather than inheritance. We could have simply created a list and created a whole bunch of inherited classes with different strategies. However, the strategy pattern prefers composition because it's cleaner and easier to understand. Another defining characteristic is that the algorithm objects all implement a standard interface, and the member variable is of that standard interface. So all of these algorithm objects look exactly the same from the outside. They implement the same interface. However, the algorithm is unique to each implementation. These two defining characteristics make the strategy pattern closely related to two different design patterns. The first one is the command pattern. The command pattern is another pattern which involves defining algorithms or a set of operations as objects which can be passed around. The strategy pattern does the same. So in that respect, it's very similar to the command pattern. Another design pattern is dependency injection. This is a design pattern which is used to set member variables of a class at runtime on the fly. We literally inject the specified member variables into a class at runtime. Since this pattern also uses composition, it's again very similar to the strategy pattern. Things are never very clear unless we see a real example. So let's see how we can implement the strategy pattern. You have code here on screen. Let's go through it step by step to see how the strategy pattern is implemented for sorting strings. Here we have a comparator which allows you to sort string, always positioning Donald Trump first if that name is present in the list. Otherwise, the sort is simply lexicographically. So let's see all the bits and pieces which go into making the strategy pattern. The very first thing here is we have to create and instantiate the comparator class, which we do by calling new comparator, passing in string as a generic parameter. So we create and instantiate this class which implements a comparator in a single line. We do so on the fly when we pass it in to the sort method. We could also have had this object ready earlier and pass it in at that time. The next step, the comparator function or the comparator interface has only one member function, and that's the only thing that need be implemented. We do that on the fly. The member function is compare. It takes in two strings because string is the generic parameter that's passed in as a template parameter, and it returns an integer. So here we have the compare implementation. Takes in two strings and returns an integer. The method we pass it to is collections.sort. So we pass an object of this algorithm, which is the comparator, into the collections.sort method. The collections.sort method will simply sort the list of strings that it's being passed in by using the logic in the comparator to compare the objects. In this way, we can create as many different comparator objects as we like. There is no limitation, each of which can define a different sort algorithm, and on the fly, based on user input or anything else, we can choose the algorithm we want to sort with. Earlier in this class, we briefly mentioned the concept of dependency injection. This is a widely used and very powerful technique by which we can set up member variables of a class on the fly. Now, what's the advantage? Now, if your class happens to be very complicated, which has a whole bunch of dependencies, we don't want to create massive number of constructors and instantiate these member variables by using constructors. Instead, we'd rather have them injected into the class on the fly. This really simplifies the process of object creation. Now, it's fundamentally similar to the strategy pattern because of its reliance on composition to instantiate member variables. For these reasons, especially the fact that it's widely used and is fundamentally similar to the strategy pattern, it's worth exploring in more detail. So let's look at dependency injection and how it can help us as a part of the next class.